Anyways, so I'm Sylvie, and I'm very happy to have the opportunity to be here virtually with all of you. You can hear me fine. Sorry, there's a bit of an echo on my side, but it sounds okay.
Yeah.
Okay, perfect. So in my talk today, I will be discussing climate scenarios, risk, and the importance of the 1.5 degree Celsius target. So before we get started today, I thought I would just share a little bit about myself. I joined the Canadian Centre for Climate Services as a physical scientist in the summer of 2021. I work on the support desk here, where I help people to find and understand climate data and information. And I live and work in Cathet or Powell River on the lands of the Tla'amin people. So first of all, we would like to acknowledge that climate change is closely connected to colonialism, and Indigenous peoples have been resilient to changes imposed by colonialism for hundreds of years. In the 2022 Intergovernmental Panel on Climate Change report on impacts, adaptation, and vulnerability, scientists recognize that colonialism is a historic and ongoing driver of the climate crisis, which has increased both the effects of climate change and the vulnerability of specific people and places. Indigenous peoples have a wealth of knowledge and skills when it comes to ecosystem stewardship, as well as resilience in the face of changing conditions. And climate change may place an increasing burden on Indigenous communities that are already impacted by colonialism through the loss of biodiversity and environmental degradation. So the context of this talk today is that recent climate events have highlighted the need to prepare for a climate that's considerably different from the climate we've known in the past. And the most recent IPCC reports highlight that every increment and even small increases in global warming escalates the impacts of climate change, and that adaptation will become more difficult. Climate models project a range of possible future pathways at global, Canadian, and regional levels based on low to high greenhouse gas emissions. And so the climate data and information from these models can be used to support mitigation and adaptation planning and action. So our presentation today will touch on these points and then draw on three key reports from the Intergovernmental Panel on Climate Change, or the IPCC. So these reports are the 2018 Special Report on the Impacts of 1.5 degrees, the sixth assessment report on the physical basis, that's from August of 2021, and then the recent synthesis report that was released in March of 2023. And so these reports also underscore that climate change is widespread, it's rapid, and it's intensifying. And the reports issue an urgent call to action. They note that vulnerable communities who have historically contributed the least to climate change are disproportionately being affected by climate change. The IPCC's sixth assessment report is unequivocal that warming of the climate is due to human influence, and that only with urgent, deep reductions of greenhouse gases can we limit global warming to below 2 degrees Celsius. And so here we can see some projected changes in temperature and precipitation around the globe for 1.5 degrees of global warming, shown here, for 2 degrees of global warming, shown in these graphics, and then for 4 degrees, shown on the right. The top graphics, so these three, show simulated change in annual mean temperatures, and then the lower graphics show the annual mean precipitation change forecast for the globe. So the degree of warming will not be the same everywhere. From this figure here, we can see that we know that Canada is warming faster than the global average, and this is likely to continue into the future. Also, as shown in these bottom graphics here, some places may see an increase in precipitation and others may see a decrease. I'd also like to highlight that these types of figures don't show us the whole picture. So, for example, the precipitation figures don't tell us information about extreme events like downpours and storms or localized droughts. The most recent report from the IPCC shows that risks and projected adverse impacts from climate change escalate with every increment of global warming. And finally, they will occur at lower levels of warming than previously assessed. This figure here shows that different global choices in greenhouse gas emissions will lead to different amounts of global warming. So from very low, shown here with the light blue line, to very high with the dark red line. The lines on the graph here represent a range of warming associated with different emissions scenarios. And so for example, the lighter red line marked as high here, and then the dark blue or the black line marked as low show a high and a low emissions scenario. The lines represent the median or the average from the models, while the shading shown around the lines illustrates the range of possibilities specifically for the high and low scenarios. The gray shading on the left over here represents the climate of the recent past. And I think Nina is going to go into a little bit more detail about the emission scenarios in her talk. I'll also note here that about 1.1 degrees of warming has already occurred, shown with this straight gray line here across the graph. And so I know there's a lot of information on this slide, but I'll just highlight a few interesting points shown here. So first of all, the graphic on the left here is the same one that we just saw in the previous slide, and it ties into the graphic that's shown on the right. We have added a horizontal yellow line here to emphasize 1.5 degrees of warming, and we can see what that means for different kinds of impacts, or what the IPCC is calling global reasons for concern. There's two bars here shown for each of the 5 areas of concern. And here it's important to focus on the wider bar that's on the right, because these are from the most recent assessment. So the IPCC calls these bars burning embers, and they're used to show the level of risk for each area of concern. The color change, so from white all the way up to purple, shows how the risk changes and increases. So for example, you can see that for the first area of concern here, unique and threatened systems, the moderate risk, or the yellow, has already changed to red at about 1.1 degrees of warming. So that's here. This shows a high risk or potential for adverse consequences. This reason for concern, as it's titled, refers to human and ecological systems with distinctive properties. So this is like the Arctic or mountain glaciers and biodiversity hotspots. You can see here with the yellow horizontal line at 1.5 degrees of warming, the risk shifts from red to purple, which is a very high risk. So next we can look at extreme weather events, shown here in the next bar graph. And so these are events like heat waves, heavy rain, drought, wildfire, coastal flooding, and the impacts on human health, livelihoods, and ecosystems. Here you can see that the risk doesn't shift quite as quickly. So at 1.1 degrees, the shift from moderate to high is starting, and then at about 1.5 degrees, the risk is high, and then it shifts to very high at about 2 degrees up here. Finally, the reason that the IPCC is showing 2 risk bars here, as I just mentioned, is just to show that the risks are now assessed to occur at lower levels of global warming than they were in previous assessments. So in other words, it's now understood that less warming leads to higher risks, and impacts will occur earlier than we thought before. The IPCC has also assessed risks to land-based and ocean and coastal ecosystems, again using these burning embers bars. Here we want to highlight 3 areas of risk, again paying attention to the yellow horizontal line showing 1.5 degrees of warming. So firstly, the risk of wildfire damage here shifts from moderate to high, so yellow to red, at 1.5 degrees Celsius. And remember, this is a global aggregated risk, so it's not speaking to a specific risk at a community level, but it's showing an overall trend direction from lower to higher risk with more global warming. The biodiversity loss shown here is similar, but here you can see that the shift to very high risk, so from yellow to red to dark red, shifts rapidly as warming increases, with very high risk, or the purple color, occurring at around 2 degrees. That's here. Looking at kelp forests under the ocean and coastal ecosystems on the right here, From 1.5 to 2 degrees, the risk has been defined as moderate. However, it does start shifting to red and to dark red or high risk just around 2 degrees up here, and then very high risk or purple after 3 degrees. So looking at projected temperature change in Canada for 2 different emission scenarios, we have the low emission scenario shown here on the left, and then a high emission scenario shown on the right here. It's important to note that Canada has warmed at about 2 times the global rate. So say 1.5 degrees of warming globally translates to about 3 degrees of warming across Canada. However, warming in Canada is not uniform, and regions across Canada will feel the impacts differently. For example, as you can see in these graphics, Northern Canada has warmed at about 3 times the global rate. And these different rates of warming are expected to continue in the future. These warming projections for Canada do hold true across the emission scenarios as seen in these figures. And as I mentioned, on the left is a low emission scenario, and this is equivalent to about 2 degrees Celsius, 2 degrees of warming under the Paris Agreement by the end of the century. On the right, we're looking at a high emission scenario, which has quite a bit more warming, or just over 4 degrees by the end of the century. In considering what kinds of impacts we can anticipate with different amounts of warming, we can learn from experience because we're already experiencing higher temperatures and the associated impacts. So while a single event cannot be attributed entirely to climate change, there are specialized climate scientists who work to figure out the climate change signal in extreme weather events and how likely those events would have been in a past climate. So for example, for the BC heat dome in 2021, the weather attribution specialists found that in a past climate, this event would have had about a 1 in 150,000 chance of occurring. So it would have been an extremely rare event. In today's climate, the heat dome has about a 1 in 1,000 chance of occurring. So it's still a rare event. However, when we reach 2 degrees of warming, similar events could happen on a 1 in 5 year or a 1 in 10 year basis. So they'll become more and more common. As we know, the international community is working to limit global average warming to 1.5 degrees Celsius, and there are a range of plausible futures depending on the emissions choices made by the global community. It's important to be prepared for different futures in the event of that the 1.5 or 2 degree pathways are not met. Adapting to climate change means planning for the increased risks that a change of possible future climates may bring. And so from a risk assessment perspective, this means considering a range of plausible futures and therefore a range of emission scenarios. In addition to thinking about how best to achieve the low emissions pathway, so the blue line shown here, we recommend also considering medium and high emission scenarios and their associated risks, so shown here with the yellow and the red lines on the graph. Considering a range of scenarios allows us to evaluate how tolerant or vulnerable our infrastructure, communities, and ecosystems are, and enables us to be better prepared for a range of possible futures. And so this figure is showing us the projected change in temperature for Canada under all 3 of the emission scenarios by the end of the century. And you can see how different future temperatures could be under all of the different scenarios. The change in temperature here is on the y-axis. So finally, the main takeaway from this figure is that it's important to consider a range of plausible futures in order to be best prepared. Also, Western science can be used to complement Indigenous knowledge to inform adaptation and to prepare for the future impacts of climate change. So lastly, today, I just wanted to share some tools and resources that are available. The Canadian Centre for Climate Services can help users find and access climate information and data, as well as direct people to relevant resources. There is a lot of data available and there's many different ways to access it. Our website, so CCCS website, has links to other resources and portals, including the Climate Atlas of Canada, here, climatedata.ca, and then PAVIX, or Power Analytics and Visualization for Climate Science. The Climate Atlas is a good website to start with because it combines climate science, mapping, and storytelling to bring the global issue of climate change closer to home. It's also a good starting point because it has really easily accessible data. climatedata.ca in the middle here is a great resource for those looking for higher resolution climate data. The data on climatedata.ca is available at the 10 by 6 kilometer grid size. And it's also great for those who wish to explore climate data in more detail and even undertake their own climate analyses. And on climatedata.ca, you can search for any location across Canada. And then finally, PAVIX is geared towards data scientists, academics, and others who want to go really deep into the data. I also want to highlight a few specific resources, which I think may be useful for the discussions we're having today about building. The role of the CCCS and climatedata.ca is to provide access to high resolution climate data to users and decision makers, giving them the ability to visualize and analyze climate data, thus supporting their climate adaptation planning. So in climatedata.ca, you can view data by sector, and there's 4 sectors that are currently available. There's buildings, health, agriculture, and transportation. And in each of these sector modules, introductory information on the impacts of climate change, as well as case studies that give examples on how climate data can be used to support decision making are provided. The building sector module on climatedata.ca includes information and data from relevant variables to support the building sector. So it provides future projections extending to the year 2100 for many of the key climate variables of relevance to the building sector. And so these relevant climate variables could include minimum and maximum temperature, heating and cooling degree days, maximum 1-day total precipitation, also data on freeze-thaw cycles, for example. Finally, another key resource, which does also include specific data for Lytton, is the report known as the Climate Resilient Buildings and Core Public Infrastructure Report. It's from Infrastructure Canada, shown here. This report provides climate model-based estimates of future temperature, precipitation, moisture, wind, snow, and ice conditions that are all relevant to the National Building Code of Canada. So that concludes my section. I know that was quite a whirlwind, but I really appreciate having the opportunity to talk today. If you do have any questions, don't hesitate to reach out to us at the Canadian Centre for Climate Services. We're always here to support people in their climate data and information needs. So as a reminder, the CCCS has a support desk. You can email, submit a web form, or even phone us at the number shown here if you have any climate-related questions, particularly about future climate projections and data. Thank you.
Yeah, the screen that the
camera's over here.
Can you hear me now?
Yes.
All right. All kidding aside, told you the Earth's air, land, and water is heating up. There's no going back to yesterday. So why would you build Lytton for yesterday's weather? Why are we having a building symposium with the future in mind? We have an opportunity to design homes and supporting systems and infrastructure to handle what everybody's talking about. What an incredible opportunity. Don't get me wrong when I say, don't tell that to the people of Lytton. Some of us lost our home, built in 1973, never designed for the heat, never designed for the cold or the fire exposure we have today. I'm going to build my home for the next 100 years. I'm going to go out here and I'm going to look at the tables and I'm going to pick the products and the systems that I need. And just letting you guys know what's coming. Now, even if we throw the trillions of dollars at harm reduction, that means quit releasing GHGs into the air. Even if you throw the trillions of dollars of getting it down, it's called lag, time, and inertia. It takes time to stop us. We committed to 1.5. We're going to stop the global temperature at 1.5. Did you see they said, oh, and here's forecasting at 2.4? Kanaka Bars already forecasted a 6-degree change at Kanaka. Right? Prepare. What do you say? What's that old saying? Hope, prepare for the worst, hope for the best. We are facing a global existential crisis. Climate change is real and we're living those effects now. And as we segue into the next presentation, and I'm no so sorry. And what happens is Nina, there's no, and Amanda and Silvie, if you guys want to listen in, we have 2 speakers featuring next, because what climate change is doing is impacting our natural and built systems. How do we know this? Because your next speakers are going to tell you what happens when it gets too hot and get too cold in theory. So step outside. Remember, everybody, this is being recorded. Paul doesn't have a presentation, but Technical Safety BC does. We're not gonna abandon you guys. You get to hear now. Why would the recovery manager, Patrick? I owe you one. Didn't I say ask him what time you can start rebuilding? Is that why it was? Anyway, I digress. We still have, and we will delay. So we want Paul and Technical Safety BC to do their presentations. Go eat, it's being recorded. What you've heard for those, if you have questions, comments, or concerns, this is being recorded so you can locate the people afterwards. If not, ask the mayor or a chief. I'm retired, chief, remember? So Paul, I'm going to turn it over to you now. Paul said no presentations, but I'm hoping that Paul will just tell you with the frankness. So Paul is from Industry for Catastrophic Loss and Response. Thank you so much for coming over.
Thank you. Oh, do you mind if I bring mic on you? Go for it. Here you go.